Hey guys, let's do problem of the day. Load please. Thank you. All right, 15 minutes to the clock. Here we go. Smallest integer divisible by k. Given a positive integer k, you need to find the length of the smallest positive integer n such that n is divisible by k, and n only contains the digit 1. Uh-huh. Okay. I see. All right. Oh, so All right, excuse me. Um, so for this first example, for 1, yeah, 1's obviously divisible by 1, and 1 only has a 1, 1, so its length is equal to 1, so that's why the output is 1. Let's consider 2. All right, negative 1, it's not divisible. Let's consider 3. Okay, 3. So we're trying to find, so we start with 1. Is 1 divisible by 3? No. 11? No. 111? Probably, because their answer is 3. What is this? 30 something. Maybe it's 40 minus 9, 38. Okay, 38. Um so yeah. So 111 is divisible by 3. So 111 has 3 ones, so our answer here would just be 3. I mean, okay, it makes sense, but I have no idea how to do this. This is a math problem. Yeah, and n may not fit in a 64-bit. Ah man, love doing these problems where can't store the numbers. All right, how can we do this? Um, I'm generally not good at these math problems, so I honestly don't know like what techniques I can even refer to. Let's see if I can pull something out. All right, let's work through an arbitrary number. Let's do like 14. But like I don't even know what's gonna be. I need a calc for this, dude. All right, let's do 14. Let's stop being a baby about it. Let's do 14. Wait, okay, observation. It always ends in 1, so the number has to be odd. Okay, we can't do 14. We could do 15. Now let's do 13. Okay, pulling out the calc for this. I mean, there's no reason because I can't just do just this basic testing like this because this number might not fit in the 64-bit integer. And yes, I think I can store it in Python because Python's just like that. But like, if this isn't a real interview, I don't think they would want me to store this number n. So I can't just keep storing this and testing. So I don't know. I don't really need the calc yet. How can I do this without storing the actual number? Dude, I have no idea. Um, how do you do this? Okay, 1 divided by 13. No. I have this remainder 1. Can that help me? Okay, let's try with like 7 actually. Okay, so I'm at 11. I know 11 is not divisible by 7. What is even like what number would be even divisible by 7? I need my calc for this. Sorry, give me one sec. Nope. Nope. Well, I've tried 11,000. It's not working. 111,000? Oh, okay. 111,000 is visible. Okay, so 6 zeros should be our answer. Like, dude, what? Alright, anyways. So, yeah, 1 divided by 7, remainder 1. We get to 11 divided by 7, remainder 4. Can the remainders help us? 11 mod 7 is 4. Okay. Yeah, but now when I add... Okay, but I'm essentially adding 100. Right? No. Yes. It depends on like, how many tens or how many digits I already have. But when I add a new number, like I'm adding like either 10 or 100 or 1,000, and then the remainder just carries, I think. Let's see. So at this point, I just did 11. So now to get to 111, I need to add another 100. So using this previous remainder, I'd have 104. What's 104? Oh, dude. 14 times 7, 98. So this is 6. Okay. And so next I'm adding 1,000. So this is 1,006. Mod 7 is what? 1,006 divided by 7 is 143. 143 times 7 is 1,001. Okay, so this is 5. And now this is 10,000. 10,005. I'm still storing this like huge number, like 10,000, 100,000. This is also not 10,005. Let's just see if this even works. Um, 10, 1, 2. I can't type it out. Wow, I'm so bad. Okay. 10,005 divided by 7. 1429. 10,003. So this is remainder 2. Okay, let's see if this works. 100,002. Right? Mod 7 is what? Oh, it's a whole number. Okay, so this is a whole number. So it's mods. It's 0. So I mean, this worked. The only thing is like. I still can't store this like 10,000, 100,000, a million. It's gonna go out of bounds. I don't know. I honestly might just have to give up and just work through that tutorial. Yeah, I don't really know. Okay. A checking loop. We need to do 2 things. Check if the required number n exists, find out length n. The second one is easy. We need to keep multiplying n by 10 and adding 1 until n mod k equals 0. However, since n might overflow, we need to use a remainder. What? While the remainder is not 0, sure, n is equal to remainder times 10 plus 1. Remainder is... Oh. Is that essentially what I was doing? So many emails. While the remainder mod k is not equal to 0, n is equal to remainder times 10 plus 1. I'm having trouble understanding that. Since the remainder and n have the same remainder of k, it's okay to use remainder instead of n. Why do remainder and n have the same remainder? What is remainder? I mean, like, I guess, is this essentially what I was doing before? Honestly, don't know. I might have to read that again, but let's move on. Now, the only problem is how to check whether the required number n exists, and if the n does not exist, this while loop will continue endlessly. Yes, however, the possible values of remainder are limited to ranging from 0 to k minus 1. Oh, the different modulo classes, right? Okay, so if you have all the modulo classes, then you just... wait. Oh. We're getting different modulo classes here, 4, 6, 5, 2. So maybe if you get a loop, then you know that's an infinite loop. Let's see. The remainder repeats. Also, if remainder repeats, then it gets into a loop. Hence, the while loop is endless. Yeah, okay. I understand that part. Yeah, that makes sense to me. I just don't understand how n and remainder have the same remainder. I still don't even understand what they're doing here. Let me see the actual code maybe. The classic pigeonhole principle. All right. Okay, well, I mean, like, yeah, this is exactly. Well, wait, where are they doing the set? Where's their set? Why don't they need it? What? I'm gonna ignore that. Wait, where's their set? This made sense to me. Oh, right. I probably should have actually read this part. Okay. Furthermore, we can improve this argument if we recall the number of possible values of remainder. Yep, it's limited in this number k. As a result, if the while loop continues more than k times and it hasn't stopped. Ah. Okay, that makes sense. This makes sense actually. So you only need to run it k times. Yeah, okay, I get that. I get that. Now I just need this to clock to me. It's not clocking to me. So remainder starts, let's run through an example, I suppose. Let's use, yeah, sure, let's use k is 3. So k equals 3. It's not clocking to me. Okay, so the remainder is set to 0 for length n in a range 1 to 4. So it's going to do 1, 2, and 3. So 3 iterations. Are we actually using this length n? Oh, we are. Oh, okay, because it directly corresponds to the... Okay, I understand that. I understand why we go from 1 to k plus 1 instead of just like 0 to k. Because you can use it to directly correspond to the length. Makes sense, makes sense. So the remainder, okay, let's run through this. So this is going to start length n is 1. Remainder is going to be 0. Yeah. 0 times 10 plus 1. So 1 mod k. So this remainder would be 1. Okay. Sure. I'll allow it. Now let's go to length n is 2. So now length n is 2. The remainder becomes 1 times 10, which is 10 plus 1 is 11. 11 mod 3, which is 2. Okay. And then we finally get 3, where length of n is 3. And then we get remainder, which is 2 times 10 plus 1. Oh, I can't understand why. We multiply the remainder by 10. Maybe someone in the discussion will help me. Ah, yes, I concur. Yep, it's too hard. Myself unsure why so is. I think I figure out eventually. So just see here. Yes. Okay. Let's. Whoa. Okay. Let's read number 3. Why can we discard the previous number and just keep track of the remainder? Take k equals 17 as an example. Let's consider one random case with n is 111. The remainder will be 9. I'll believe that. Notice how 6 times 17 can be, wait, what? Oh. Well, yeah. Yeah. The next n will be 1111 times 10 plus 1. If we replace 1111 with 6 times 17 plus 9. Okay, this is what I need. You ignore this part, and then you end up with just 9 times 10 plus 1. Okay. This is what I needed. This makes sense. Okay, I understand this. Yeah. Because this mod, we're doing everything in this equation mod, mod k, mod 17, right? And so, obviously 6 times 17, this is going to evaluate to 0, and then you just get 9 times 10 plus 1, mod 17. All right, let's see if I can actually code this. So the remainder is 0. This is for length in range 1 to k plus 1. So we'll do remainder times 10 plus 1. Oh right, and then we have to mod everything. I guess I can just do it like this. Remainder times 10 plus 1, mod k. And then if remainder is 0, and we'll return length. Otherwise, we'll return -1. Wow, this problem sucked. Just kidding. It's a skill issue, honestly. It's a skill issue, but I understand it now. Yeah. It makes sense now. Well, hopefully seeing me humbled was enjoying to you, but hopefully you were able to also enjoy the process of getting through it and getting to the solution and understanding it. So thank you for watching and sticking along. Yeah, I'll see you around.